Let us look at polar subtangent and polar subnormal. So again, we start with a curve. Let's say this is r is equal to f theta. Take an arbitrary point on the curve P. Then we take the radius vector OP vector R. Draw a tangent T at P intersecting x-axis at A. So let's draw a tangent at P named as T intersecting the x-axis at A. Draw N perpendicular to T at P. Draw a line S perpendicular to the radius vector through the origin. So through this origin, we have to draw a line perpendicular to this radius vector. That is S. Intersection of S and T be T1. S and T be T1. And intersection of N and S be N1. Now ON1 is called the polar subnormal. ON1 is called the polar subnormal. And OT1 is called the polar subtangent. Let's take it one by one. Triangle OPT1 is right angled because S is perpendicular to OP. Let beta be equal to angle OPT1, angle between the radius vector and the tangent. So let's mark that tan beta is equal to OT1 opposite side by R, that is the adjacent side. Since tan beta is equal to R times d theta by dr, remember previously we have seen this, we can say R times d theta by dr is equal to OT1 by R, which means OT1 is equal to R square times d theta by dr. So this is the expression for the polar subtangent. Okay, now let's look at polar subnormal. OPN1 is right angled triangle. Angle OPN1 is equal to angle N1PT1 minus OPT1. Yes, this angle is equal to the complete angle minus this angle. Now remember N1PT1, the complete angle is 90 degree because line N is perpendicular to this tangent T. So which means angle OPN1 is equal to pi by 2 minus beta because OPT1 is beta. Now tan of angle OPN1 is equal to the opposite side, that is ON1, divided by the adjacent side, which is R. That means tan pi by 2 minus beta is equal to ON1 by R. Tan pi by 2 minus beta is cot beta. So cot beta is equal to ON1 by R. Tan beta is equal to R by ON1. We take the reciprocal on both the sides. So reciprocal of cot beta is tan beta is equal to R by ON1. Now tan beta is what? R times d theta by dr. So R times d theta by dr is equal to R by ON1, which means ON1 is equal to dr by d theta because R and R gets cancelled. This is our polar subnormal. So we have found the expressions for polar subtangent and polar subnormal. Again, let me remind you, there is a link to a PDF book which describes all these things in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.